A blessed day to everyone. Thank you for joining me for this discussion. I hope you checked out my previous two videos on my philosophy, which I call the philosophy of Darinism. And that philosophy is based on an analysis of Genesis chapters 1, 2, and 3, and on my analysis and my review of existence based upon current uh, based upon academia, based upon current knowledge, and it's just another take, just another look at what we have, and just providing another perspective. So I call my philosophy Darwinism, and it is the opposite of Darwinism, in that it is a philosophy of creation. Um, Now, I do go in depth in terms of the philosophy in my book called Existence, God, Man, Society, and Nature, which you're seeing in the background. Existence, God, Man, Society, and Nature. It's available at www.amazon.com. So if you type in the name of the book, it'll crop up, or you can type in my name and you will see 16 books come up, including uh, that particular book. Um, no, so today, in terms of the philosophy of Darwinism, I want to take a look at movement, force, and mass. So as we get into the discussion, we'll see what I'm talking about. All right. Now, just to review from the last, from the second presentation I'm doing that I did in the series, I I concluded that heat is mass. Mass is heat. So here, and what happened was we looked at Albert Einstein's famous formula, E equals mc squared, and we took a c term to be a constant and just realized that energy is mass. Energy is mass. Now, mass is a thing, so if energy is mass, then energy itself must be a thing. Now, that thing cannot be an ability, okay? We want it to be a physical thing. So energy itself has to be a physical thing. Mass is energy, all right? Now, based on the last discussion that we did, we said heat must be that energy term. Heat would substitute in that formula, and it would be appropriate for heat to come into that formula. And what we see then is that what if we put heat in that formula, we get heat is a thing, a physical thing, and so heat is mass, or mass is heat. And we considered some of the evidence when we said, well, when we have nuclear reactions, when mass is lost, whenever mass is lost, it's always lost as heat. Light does escape it, but as later on in our discussion, we'll see what light is. But light is massless. So the nuclear reactions, whenever mass is lost, it's lost as heat, because heat is mass. Whenever stars die, and there's an intense area of heat left back, because it's heat that actually made the mass of the stars. All right. Now, also when you have these high-speed collisions, right, that where they're smashing protons like in CERN, um, when you have mass escaping and mass loss, you also have heat loss, and so heat is mass. Now, we also concluded then that the dark matter that's in the universe that seems to mystify everyone. It's actually heat, and it's they know that there's mass there, but they can't tell what it is. The mass is heat because heat is mass. So heat that they use to, they use heat signatures as one indicator that there's this mass that's there, but um, heat isn't just merely an indicator of of the mass. Heat is the mass. Heat doesn't just indicate the thing. Heat is the thing in itself. All right. So that's a review from last time. No. So mass. So then we're going to consider what is our unit of mass. Mass can be broken down, right? And you know, if we have any mass, we can break it down. And what is mass really? It is heat. Our most basic unit of mass is heat. So what we end up with is heat is energy, which is mass. Now, heat units right, can be accumulated, or energy units can be accumulated to make greater mass. So everything that we have that's matter or some presence of mass in the universe, it's really accumulated heat. Now, that leads us to some issues related to mass. Well, one thing we want to find out, well, how does it stick together? These units of heat, if we have these units of heat, how can they stick together as mass? How can they come together and accumulate to form something, known as mass, or to form an object, or to form stars and planets? What keeps these units together? And the other thing is, what makes it move? What makes a mass move? Okay, so now what we're going to do is consider a thought experiment, and what we're going to do is let's take an object like an iron, an iron equaling the mass of the Earth, this massive iron object. And what does it have? What do we know that it has? It has gravity, it has electricity, it has magnetism, right? Now, the gravity at that size is pronounced, at that mass is pronounced. Now, let's say we break down the object, right? If we half it, if we quarter it, those fields are going to be expressed, right? Albeit to a lesser degree of magnitude. So if we half it, right, and we throw away half of it, it's still going to have gravity, but not as much gravity. Electrical charges are going to be there, but they're usually neutralized within the object itself, within the mass of the object, right? But if we keep breaking it down, all these properties are still going to be there, right? These fields are going to be there: gravity, electricity, magnetism. Well, if we break it down, our iron object, to an iron atom, the fields are still going to be expressed. Gravity, however, is going to be very, very small, to the point where it's negligible. Electricity is going to, then you're going to notice that electricity is going to be divided between fields, opposing fields. The protons exerting a positive electrical field, the electrons exerting a negative electrical field. And of course, the magnetic field is produced by the motions of the protons and electrons. All right. Now, protons and electrons, and there are other particles there. We have neutrons also in the nucleus. Protons, electrons, protons and neutrons in the nucleus, electrons that are orbiting the nucleus, those are masses, but those aren't the most fundamental unit of mass. They can be broken down. Protons, neutrons, electrons, they can be broken down into their constituent units, which is heat. They're all made out of heat. Now, now, breaking down the protons and electrons into their constituent units, their heat units, implies that the units themselves retain the properties of the larger product. That means the units have properties of the protons and the electrons. Now, each energy unit represents a unit of heat, that is a unit of mass with an intrinsic gravitational and electrical field and a magnetic field produced through motion, right? Now, when the energy units with their properties accumulate, larger masses are produced with these properties. So the units themselves must possess the intrinsic properties um, of gravity, electricity, and a magnetic field produced on motion in order for the larger product to express these properties. Because what happens is the larger products are made out of these units, and all it is that the units are coming together and they're and with their properties, and they're manifesting them in the larger masses. Okay. Now, just to caution you, this doesn't imply that electrons are just made up of negatively charged heat units, and protons are all made up of positively charged energy units. Okay, there's probably a mix of negative and positive charges in the electrons, right? And there's probably a mix of negative and positive charges in the protons, but it's just that with the protons you have an excess of positive charges that gives it an overall positive charge, and with the electrons you'd have an excess of negatively charged energy units. All right, so the philosophy of Darinism basically says that masses, when they express certain intrinsic fields, and which are the gravitational field, electrical field, magnetic field, right? They express these fields, and the reason why they're expressing it because they're very units. The energy units that they're made of actually express these fields to a lesser degree. All right. So now, heat units express the fields of gravity, electricity, and magnetism, as well as they respond to them. So they don't merely express them, they respond to them. So one heat unit will express these fields, but it will respond to another heat unit or other heat units expressing those fields. All right. Now, what we're going to do in this philosophy of Darinism is call these fields electricity, magnetism, and gravity. We're going to call them movement fields. And what it is that why we're calling them movement fields, because the interaction between an energy unit and a movement field causes the push or pull on the energy unit, and locally we can say a line of action from any movement field on an energy unit that causes a push or pull. We can refer to that as a force, but there's a movement field, a general field that's there, and the field acts on an impacted energy unit or impacted mass for that matter. And and locally just considering the mass in with the impacting line of action from that field, we can say, well, it's being acted on by a force, or the, produced by, caused by that field, or that movement field. Okay, now, so the other thing that's important to this philosophy is that gravity, electricity, and magnetism, we're going to deem them intrinsic movements because they're integrally associated with mass, right? The heat unit expresses it, and it's and because though any given field is there because of there's a mass present. Without the mass, then you don't have the field. So it's a field that's generating. It's a mass that's there that's generating gravity, right? Generating electricity, generating magnetism. So those fields, those movements, are intrinsic to the mass. Now, just as a side note, in reference to dark matter, another clue that they use to indicate dark matter is gravity, right? Because they say well, there's this gravity out there. They know it's there, and this matter is there. They can't see it. That's because gravity is intrinsically associated with mass, and mass itself is heat. Remember, we said that matter that's out there, that dark matter that's out there, is really heat. Now, later on, I'm going to stray from this term dark matter, because I want to distinguish matter later in later presentations as to what matter is versus just mass accumulated, and we'll talk about that later. But in terms of current jargon, gravity reveals dark matter, and that's because gravity is intrinsically associated with mass, and mass is heat. Okay. Now, how can mass accumulate? How can these units accumulate to make greater mass? Right? What happens is that the units are basically then interacting with each other by expressing these fields and responding to these fields. The units actually, to these intrinsic fields, the units respond to the fields, and if those units are left alone with if you get these units alone with these fields, they will accumulate into some sort of arrangement, some sort of preferred arrangements where they're all balanced, in terms of their interaction with these fields. Now, whole masses of heat units also, right, which becomes larger masses, they also interact with each other. So the heat units build larger masses which also interact with each other, and the fields also interact with each other. All right? Now, so just like you have the protons and the electrons, they're made up of heat units, and the protons and electrons also interact with each other, okay, based on the fields that they express. Now, what happens is that in terms of these intrinsic movements, what we find is that the electrical field is very strong, with respect to the gravitational field. At the atomic level, gravity is there, but it is practically totally negligible, right? But at the cosmic level, gravity has relevance in keeping planets in orbit, that sort of thing, moons in orbit, that sort of thing. Now, electricity, of course, at the atomic level, it's usually balanced out between these opposing charges, so that normally as when you get to the um, to levels beyond the atom, to molecules and or objects that we see around us, we don't notice them typically being electrically charged because there's balance between the opposing charges within the object itself. So it's the fields sort of neutralize each other. All right. Now, if mass only reacted to its intrinsic movements, we would have a static universe. That means all the masses that are in the universe would just fall into some preferred arrangement and stay still, right? Just based upon the fields that they express, they would just rearrange themselves and just stay right where they are, or just arrange themselves in some sort of static relationship, right? But we don't have a static universe. We have a dynamic universe. So that then what it means is that there are movements out there that are extrinsic to mass, but impactful in mass. Now, one extrinsic movement is light. Light is extrinsic to mass, but it is impactful in mass. Light itself is massless, and but it does have an impact on mass. Later we'll suggest there are other extrinsic movements. Now, light itself, our movements are fields. Light itself is a field. Just like the intrinsic movements, they're fields. Light itself is a field, but it's unattached to a mass in terms of it's not being generated by a mass. It's not dependent upon a mass. But it is a field, and it doesn't move translationally from any center per se. Okay? But with any given electrical field, its center is the mass producing it, and as the mass moves, the field moves with it, always as a circle around it, expanding into infinity. Now, the interaction of light, this extrinsic movement called light, the interaction of light with an energy unit constitutes the fastest speed. When light hits that energy unit, that's what produces the fastest speed that we know. We usually say it's the speed of light, but light itself isn't really moving. It's a unit that's moving. It's the energy unit that's moving. And that's what constitutes the fastest speed. Okay, we'll leave it here for now, and we'll pick it up next time. We'll examine our physical world next time. But for now, we'll just say that we leave it at that we have these heat units which basically make up all mass in the universe, and these heat units are intrinsically defined by fields of what I call movements, electricity, gravity, magnetism, and when these units accumulate, the accumulated product also express these movements, because the units accumulate, and these movements also sort of overlapped and become strengthened, or they might neutralize each other, as in, but what happens is that there is the greater product does express movement. Mass at whatever level expresses what its unit composition, expresses the properties of its unit composition, which is the energy unit. So the movements are the fields that are intrinsically associated with mass, aren't the only movements present in existence. We also have extrinsic movements, and here we just point to light as an extrinsic movement. Okay, that's it. We'll leave it there. Thanks for watching.